A mangrove is a shrub or tree that grows mainly in coastal saline or brackish water. Mangroves grow in an equatorial climate, typically along coastlines and tidal rivers. They have special adaptations to take in extra oxygen and to remove salt, which allow them to tolerate conditions that would kill most plants. The term is also used for tropical coastal vegetation consisting of such species. Mangroves are taxonomically diverse as a result of convergent evolution in several plant families. They occur worldwide in the tropics and subtropics, and even some temperate coastal areas, mainly between latitudes 30 degrees north and 30 degrees south, with the greatest mangrove area within 5 degrees of the equator. Mangrove plant families first appeared during the late Cretaceous to Paleocene epochs, and became widely distributed in part due to the movement of tectonic plates. The oldest known fossils of mangrove palm date to 75 million years ago. Mangroves are salt-tolerant trees, also called halophytes, and are adapted to live in harsh coastal conditions. They contain a complex salt filtration system and a complex root system to cope with saltwater immersion and wave action. They are adapted to the low oxygen conditions of waterlogged mud, but are most likely to thrive in the upper half of the intertidal zone. The mangrove biome, often called the mangrove forest or mangal, is a distinct saline woodland or shrubland habitat characterized by depositional coastal environments where fine sediments, often with high organic content, collect in areas protected from high-energy wave action. The saline conditions tolerated by various mangrove species range from brackish water through pure seawater, 3 to 4% salinity, to water concentrated by evaporation to over twice the salinity of ocean seawater, up to 9% salinity. Beginning in 2010, remote sensing technologies and global data have been used to assess areas, conditions, and deforestation rates of mangroves around the world. In 2018, the Global Mangrove Watch initiative released a new global baseline which estimates the total mangrove forest area of the world as of 2010 at 53,100 square miles, spanning 118 countries and territories. A 2022 study on losses and gains of tidal wetlands estimates a 1,400 square miles net decrease in global mangrove extent from 1999 to 2019. Mangrove loss continues due to human activity, with a global annual deforestation rate estimated at 0.16% and per-country rates as high as 0.70%. Degradation in quality of remaining mangroves is also an important concern. There is interest in mangrove restoration for several reasons. Mangroves support sustainable coastal and marine ecosystems. They protect nearby areas from tsunamis and extreme weather events. Mangrove forests are also effective at carbon sequestration and storage and mitigate climate change. As the effects of climate change become more severe, mangrove ecosystems are expected to help local ecosystems adapt and be more resilient to changes like extreme weather and sea level rise. The success of mangrove restoration may depend heavily on engagement with local stakeholders and on careful assessment to ensure that growing conditions will be suitable for the species chosen. Thanks for watching, and don't forget to like and subscribe. Remember, individually we are one drop, but together we are an ocean.